In this video, I'd like to talk about solid edge sheet metal. One of the big differences between SolidWorks and Solid Edge when it comes to sheet metal is that Solid Edge has its own file type for sheet metal. And with its own file type comes its own template. So we can start a new sheet metal part from a sheet metal template. Just like in SolidWorks, Solid Edge has two main ways to get started. A tab, which is drawn from a closed sketch, and a contour flange, which is drawn from an open sketch. Working with the software with subsequent features is very similar, and SolidWorks users should feel right at home using Solid Edge sheet metal. What I'd really like to show you is synchronous sheet metal, since it's so much easier. And even if you use ordered for other types of features, you should use synchronous for sheet metal. From the ordered entry in the Pathfinder, just right-click and select Transition to Synchronous. From here, there are again two ways we can start, with a tab or with a flange. So let's start with a center rectangle, lock the sketch plane, start from the origin, and create a rectangle sketch. I'll key in numbers for the size of the sketch, then exit the sketch, click in the region, and drag a thickness. To create flanges from here is very easy. In synchronous, you just click on an edge, or you can control-click multiple edges, and then pull an arrow to create a flange. You can key in numbers to be precise about the length of your flange, and you can even change the angle as you create it or after you create it. To do that, I'll click on the face I want to change, move the steering wheel to the bend radius, and then change the angle. I can key in specifically the angle that I want. You can see that this is changing symmetrically. If I don't want this to change symmetrically, then I can just turn off symmetric in the design rules. And then only one flange will change. If I want to add a flange on this edge, it's going to come off perpendicular to the existing face, but I can fix this in a couple of different ways. I could change the angle because I know what the angle was on the other face, or I could create a face relationship of parallel between this face and that face. If I create a flange over here, I could make it the same length as the other one by clicking on a key point from existing geometry. I can even angle this end face to match the other angled face. I'll click on the face, move the steering wheel, rotate the angle 15 degrees, and we're good to go. Notice that this flange isn't at the same level as the rest of the sheet metal edges. There are two ways to fix this. One way is to use a coplanar relationship between the bottom face of the flange and the bottom face of this flange. And the angled flange moves down. If I hit Control-Z, I can undo that. And the other way to do this would be just to use the steering wheel, where I can select this face and move it down to a key point on this existing flange. Either way creates the same finished geometry. To get a flat pattern, go to the Tools tab and select Flatten. You need to select a face to remain flat and an edge to specify the X direction, and then Solid Edge gives you the flat pattern for the part. There are other types of functions in synchronous sheet metal, multi-edge flange. We've already seen the contour flange and the tab, dimples, two bend corners, different types of holes. You can unbend specific bends to put in features that go across the bend, break corners, create enclosures, and even multi-body sheet metal parts. Thanks for watching.